Hi everyone, welcome to this question whereby you are going to find the residue at its pole. Now here the pole the pole is given by z is equal to 2. Remember, a pole is a point where the function is not defined, and this pole is of under 2. So we are going to obtain the residue, which will be obtained as follows. We are going to obtain our residue as follows. So it is given by our residue, R stands for residue, will be given by limit as z tend to 2, first derivative with respect to z of z minus 2, we square that, then z squared divided by z minus 2 squared. So that is the part we have there. Then which look like that, you can see this part here will cancel, so we are going to have equals. So our residue is equal to limit as z tends to 2, first derivative of z squared, which is equal to limit as z tends to 2. When you differentiate this one, it will give you 2z, which is equal to 2 multiplied by 2, which is going to result to 4. It will result to 4. So this is the question we are given here. F of z squared divided by z minus 2 squared. So you are going to obtain the residue at its pole. To obtain the residue at its pole. So to get the residue here is very simple. All what you need to do is to identify the pole, and in our case the pole is 0 is equal to 2, because at z is equal to 2, this function is not defined. Once you identify the pole now, the next thing that you do now is you use this formula, limit as z tend to 2 of d of dz, then z minus 2 squared, z squared bracket z minus 2, everything squared. Then now this one was, we have cancelled this part here with this denominator there, and now we have been left with the z squared, which is the one here. Then you differentiate this. After differentiating, you are going to get 2z. Once you differentiate, now you substitute your z, which is equal to 2 there, to obtain 4. In case you had been given something like this, f of z is equal to z squared divided by z minus 2 power 3, and you are going to identify the residue at its poles. So all what you need to do is, first of all, you identify the pole. The pole is z is equal to 2 order 3. Then residue r will be given by 1 over 3 minus 1 factorial, limit as z tend to 2, second derivative with respect to z second derivative of z minus 2 cubic multiplied by z squared divided by z minus 2 cubic. This is equal to 2 factorial limit of as z tends to 2 of second derivative with respect to z of this part here will cancel with this, the other one, and then you are going to be left with z squared. So this is 1 over 2 factorial. 1 over 2 factorial will give you 2 limit as z tends to 2. When you differentiate this twice, the answer is going to be 2. The answer will be 2, which will result to 2 over 2, which is equal to 1. Thanks so much for taking your time to study with me on how to get multiple of residue. When you are dealing with the multiple of residue and you have a pole at z is equal to alpha of under n, where n could be 1, 2, 3, 4, all the way. So to obtain the residue, the general formula is this, is given by 1 over n minus 1 factorial limit as your z tends to alpha. Alpha, it is where your function is not defined. D power n minus 1 divided by dz power n minus 1, z minus alpha power n, you multiply by f of z. F of z, it is your function which you are given. So this is the general formula for obtaining the poles, the residues at multiple poles. You simply do it 1 divided by n minus 1 factorial limit as z tends to alpha, dn minus 1 divided by dz power n minus 1, z minus alpha power n, f of z, whereby f of z, it is the given function. Thanks so much for taking your time to study with me. For more such tutorials, kindly tune on to my YouTube channel so that you may keep on learning together. Bye bye, see you in the next presentation.